a test statistic. The p-value is the area under the standard normal curve, and the area depends on the test that we're doing. So what we're looking at is that this z-score, that is your test statistic. So this is not the same one as your critical region. So in this case, the p-value is the area to the left of the z-score. So my p-value is the probability that the z-score that I'm looking for is going to be less than the test statistics. So I'm going to use TS for test statistic. Or better yet, let's say my test statistic is actually going to be 2. This would be the probability that my z-score is less than 2. If I do the right tail, p-value is the area to the right of the z-score. This is the probability that my z-score is greater than 2. And this, the p-value is the sum of the area and the two tails. So your p-value is actually going to be twice the p of either z is less than 2, or the p-value of, or twice the p-value of z is greater than 2. Just depending on what side of the tail we're on. Like I said, it's all because it's that sum of those two areas. But that z-score always comes from your test statistic. And we're just saying our test statistic is 2 for right now. So in a large company, the attitude of workers are measured with a standard test. The mean score over all employees was 74 with a standard deviation of 8. Some years ago, the company adopted a policy of telecommuting, allowing work from home. After a policy had been in place for some time, a random sample of 80 workers was given a test to see if their mean score of satisfaction had changed. The sample mean was 76. Assume the standard deviation is still going to be 8. What can we conclude that the mean level of satisfaction is since the policy change at an alpha of 0.05? So we need to figure out what kind of test are we doing here. So we were told that in the past, that the mean score of all employees was 47. So in the past, what we saw was that it was 47. So we want to know, is it different now? So some time ago, the company adopted a new policy, and they just wanted to see, like it says, it's not stated here, whether they expected that workers are going to be more satisfied or less satisfied. It's just simply that the mean level of satisfaction have changed, meaning that my alternative hypothesis is simply, sorry, I made that look like an eye. Well, my alternative hypothesis is simply that whatever the level of satisfaction is, it's no longer 74. We think it changed because we have a telecommuting policy now. So this is going to be a two-tail test. So that means that when I'm looking for scores, my z-scores, whenever I find it, whatever side it's going to be on, that my p-value is really going to be double the probability of being in one of those tails. So it's probability z to the left, and we double it, or it's 2 times the probability that my z-score to the right. Going back through all my information here, we find that we did a sample of 80 employees, and with that, their mean level of satisfaction was 76. We're assuming the standard deviation had not changed, and we're an alpha of 0.05. So my z, my test statistic, Okay, one more time. Test statistic at Z, it's going to be the mean from the sample, take away the mean from the hypothesis test, divided by the standard deviation from the population, divided by the square root of the sample size. And this is going to be 2 divided by 8, which is then divided by the square root of 80. And so I'm going to get a score of 2.24. So the probability, so like I said, this is 0, and I'm getting a positive score. So if I want my p-value, I'm just going to look at one of these areas and we double it, because then we assume that this side is just going to be negative 2.24. So I am going to do, for my p-value, I'm just going to double the probability that my z-score is in this tail, which means greater than 2.24. So if I go back to my one var statistics, I put in a region that goes from 2.24 to, let's say, 100,000, just make it big. Because when doing z-scores, the mean is 1, the standard, or the mean is 0, the standard deviation is 1. Well, what I get, or like I said, you could use a z-table, but you should get a probability of 0.01, let's say 125. Well, I have to double that for my p-value. So once I double that, then it's actually going to be 0.025. So what does this tell us? So my alpha level is 5%. So P is less than alpha. So this means I am going to reject the null hypothesis. And when I reject the null hypothesis, all I'm really saying like my stuff got messed up here. So because I reject the null hypothesis, what that means is that we're not going with this claim, we're going with this claim, which is that the satisfaction levels have changed. So there is evidence that satisfaction levels have changed. And it has changed since the new policy. Let's do one more p-test. So social scientists suspect that the mean number, okay, we're here, suspect that the mean number of years of education for adults at a certain large city is greater than 12 years. So they suspect that in a certain city, what they're saying is greater than 12. So my mean is greater than 12. That means the alternative or the null hypothesis is that the mean is 12, which I know sounds a little weird. So she will test the null hypothesis at mu is 12 and the alternate hypothesis at mu is greater than 12. She surveys a random sample of 100 adults, so n is 100, and she finds that they have a sample mean of 12.98 years of education. The standard deviation, the number of years of education is sigma is 3. We want to find and interpret the p-value and decide if it was rejected at a alpha of 0.01. So the kind of test we're looking at here is we're looking at a right tail test. So this probability here is the probability that z is going to be greater. Than whatever is going on, whatever that z-score is going to be. So once again, I need that test statistic. So I need my z-score. So my mean of my sample is 12.98. The mean of the hypothesis test is 12. The standard deviation is 3. And the sample size I have is 100. So 0.98 divided by 3 divided by 10. Let me just double check that. Okay, that's what I got. So this is a score of 3.27. So if I want to figure out, set up here, so I'm looking for a p-value greater than, or p-value for a z-score greater than 3.27. So if I do my, use the z-tables or use the calculator, like I said, we're looking for greater than 3.27. And what we get is that the probability that my z-score would be greater than 3.27, pretty high. It is 0.0005. This case, we don't double it because it's already in one tail. So we are just looking at, is my p-value less than alpha? And it is. So we are going to reject the null hypothesis. There is evidence that adults have an average education an average of more than 12 years of education.